Automatic transmission test 3. That is automatic transmission test 3. Everybody got that? You ready for me? Going to hit these questions as quick as we can. I'm going to hit you some high points and tell you stuff I might forget if I didn't do it the other way. Force is measured in pounds per square inch. Is that true or is that false?
False.
Force is not measured in pounds per square inch. Yeah, pressure is measured in kilopascals.
It can be, can it?
Yep, that is true. In a hydraulic system, an increase in force means an increase in speed and distance.
True.
Well, think about it. All right, let's look at it. We're going to go over this. We're going to make sure we understand it. I'm going to do this quick. Got a piston, got a line, got a big piston.
A piston,
yeah, hydraulic piston. All right.
Speed and distance usually aren't the output of a hydraulic system, though.
They are, too. This one here is 4 times as big as that one. It's area-wise, right? 4 times this is the one you're pushing, and this is the one that you're moving. If I move this one 4 inches with 100 pounds of pressure, how far is this one going to move?
An inch.
1 inch with how many pounds of pressure?
400.
400 pounds. The size of it is going to reduce the speed by a factor of 4 and increase the power by a factor of 4. That's almost like gears, isn't it? Think about it. The distance you're traveling, you know, it's basically like it's like a hydraulic way of changing gears. You understand what I'm doing? Hey, everybody got that down pat? There's anybody sitting here? Hey, Tyler, you're not even looking up here, huh?
So it's going to be true.
That is absolutely going to be false. Look at what it says.
Okay.
In a hydraulic system, an increase in force means an increase in speed. Well, the answer key is wrong, but you're right. If you've got a, well, yes and no. They're not even factoring in the size of these pistons.
Okay.
You got to do a lot more than just increase force. That's the point. That's why they said that was false. You actually have to. See, they didn't put anything in here about the size of the pistons. So there's a lot more to it than increasing the force. You see what I'm saying? So let's call that one false. Just make sure you understand that's how that works.
So if they were the same size pistons, then they would increase in the.
Well, if it were, yeah, it would actually be the same distance and the same force if it's the same size piston.
Yeah.
If this one here, if you move this one an inch, it's going to move that one 4 inches, and it's going to subtract. You know, it's going to. If this is 100 pounds of pressure, it's going to be 25 pounds over here. See, so you don't ever do this unless in an automatic transmission you're actually going back and forth with your servo. You know, you're releasing it one way and that kind of thing. And you saw that in the video. That Derek, you saw that, didn't you? Okay, that servo pistons and all that. You didn't see that? Okay, yeah, remember that because that's when you were taking automatic. We're going to get the manual transmission in a minute, so hang tight. Pumps create fluid pressure. Yes or no?
Sure.
No, they don't. And I'll tell you why that is. A pump moves the fluid, but it does not create the pressure. The pressure is created by restriction. Remember what I told you about that? This is really important. You gotta. I'm gonna make a chamber here. I mean, this is going to be a cylinder. It's not just. I'm just drawing it 2-dimensionally. And I've got a little port right here. It's basically a return port going back to the sump, which is where the fluid comes from. All right. I've got a piston here. I've got a spring. It's against a little boss up here. Like that. All right. I've got pressure coming in down here from my pump, and it also is going other places. Let's say it's like that right there. Okay. As the pressure comes in from the pump this way, it's going to push that spring up to the point to where it lets that pressure go somewhere else. But it has to squeeze that spring to that point. The amount of pressure it takes to apply that spring and push it to the point where it lets the pressure leak off is how much pressure you'll have in that whole circuit. You understand what I'm saying? So if let's say that something happened and this plunger stuck way up here and it never came back, and you'd have no pressure in that system. You'd have fluid flowing through it, but there'd be no pressure. So the oil pump on your car works that way, on your engine works that way, and the pressure relief valve on your transmission works that way. The pressure control valve works that way. The pressure control valve can can change technically, I'm just giving you this to make it simple, can change the calibration of the spring. You see what I'm saying? Or they can actually put a solenoid, a variable force solenoid that can pull that thing back and help the spring so that it will regulate the pressure. So your pressure regulation in an automatic transmission is extremely important. In an engine, it's not that important. It's just that you have to have a certain amount of oil pressure, and if you ever see one that the relief valve sticks in it, it's going to burn that engine up because you've got flow but you got no pressure. And where you're not no pressure, you're usually going to have some foam when it heats up, and it's not going to lubricate, it's going to cook it.
So what makes the pump pump?
The pump actually moves the fluid, but it cannot have pressure unless there's something to restrict it. And this restricts it, but it's a controlled restriction. That's right, the pump moves fluid, yeah.
So the pressure moves the pump.
Yeah, the pump actually moves. No, the pump actually is spun by mechanical means, by the engine or by the torque converter or something like that. So the pump is actually spinning by something else. But the pressure the pump is creating is actually having to go against something to resist it. And that's the only way you can have pressure. Well, a lot of people don't think about that. But I had this one guy that rebuilt an engine, and it locked up after he rebuilt it. And he says, this thing locked up before, it's locked up again. And it really hits me right here because I'm an engine guy. And I said, well, do you know where the oil pump relief valve is? Well, I put a new oil pump on it. I know, but where's the relief valve? I mean, on most of them, it's in the oil pump. On the older ones, it's got a little plunger and a spring inside the oil pump. And sometimes I put some washers behind that spring to make it a little stronger to raise the pressure. I mean, when I was, that's old school. Don't hurt a thing. And I've done that before when it would help. But anyway, he says, I says, in this one, and I picked up the timing cover, I said, the relief valve is in here. And so we took that little plug off, and the relief valve was hung. Just like I'm seeing this right here. And he didn't catch that, and he had to pull that motor all back apart and rebuild it again. See?
So even on the diesel, that oil pressure still works the same?
Absolutely. The same way. The same way. I mean, so if this spring gets weak, or if it breaks, or if you get little particles of crud in here that causes that piston to stick, you're not going to have any pressure. In an automatic transmission, if you ain't got no pressure, it ain't moving. It's just going to sit there. Now, Abby's tried to move even when there was no pressure at all because it was locked up inside, boom, and it'd kill the engine. All right. Now then, I skipped number 4. Without a functioning vent, the pump cannot circulate the transmission fluid from the reservoir. That's true because what's it going to do? It's going to suck a vacuum on it. You got to it's got to have atmospheric pressure pushing on it so it can create low pressure and move that fluid. If you suck out of a straw, you're actually making start with a little place in your mouth, you're making it bigger, and that creates atmospheric pressure differential between your mouth and what's pushing on the fluid. If you're on the moon, you can't drink through a straw. Got me? You can't drink through a straw unless there's atmospheric pressure helping you. That's just one of the basic principles of, transfer. Physics, whatever. All right. All pumps removed for service require a visual inspection. That is absolutely true. If you take a pump off and you don't visually inspect it, you have rocks in your head. You're a second-rate amateur. All right. I saw somebody put a second-rate amateur thing up here on the board the other day. All right. Most valves in automatic transmissions are check valves. That's not true. There are check valves in there, but most of them are spool valves. They're not check valves. Glands, valleys, face, and spring are all parts of a typical spool valve. You know what a spool valve is, right? This is kind of what I do right here. A spool valve, you've actually seen a picture before. Looks like that, except better than I do it that time. A spool valve, and you'll usually have a spring over here, and as it moves, it's going to move. It's going to allow certain passages to connect with certain other passages, and that's what's in your valve body. You got me? Like if you can look at the fluid map in some of these transmissions out here, and it looks like a road map of Clarksburg or something. But if you start checking in 4th gear, it'll be red where the fluid's going, and it'll tell you which clutches it's going to and all that kind of stuff. It's pretty cool if you're actually doing that. But anyway, that's what a spool valve looks like. And it's inside a bore, and there'll be different, passages coming and going off of it, and as it moves, it's actually going to open that passage up. And sometimes it'll connect 2 passages and let fluid go through. You know how when you take the valve body off an automatic transmission, you look at it and you go, oh gosh, this looks like a maze or something, You don't really have to understand that. If you're going to check the thing, I was telling him they got a plate, or telling Daniel, they got a plate you can bolt on there with a gasket if you want to buy one, and it's got all these different numbers on there, where it says, 3, 4 apply, 1, 2, the intermediate clutch, and when you put your rubber blower on there on the bench, and you apply that pressure, you'll hear that clutch go, thump. Or you can actually test the clutch on the bench with air pressure and all that. All right. Let's see, but lands, valleys, and spring are all parts of a particular spool valve. Spool valve, that's right. There's your valleys, and here's your lands, and so on and so forth. There's the faces and everything. And what they do is they'll make some of these bigger and smaller. They'll step them up and down, and that'll have a lot to do with how the pressure interacts with the valve. A gerotor pump may have a constant displacement or a variable displacement. What do you think? A gerotor pump? A gerotor pump. You know what a gerotor pump is? You've seen one. You just don't know what it is, right? Anybody know what a gerotor pump is? A gerotor.
All of something be able to have constant and variable.
The only one that's got constant and variable pressure is a vane pump. And what happens on the vane pump, you've actually got it pushing it, but the whole housing moves against the spring to change the amount of displacement it has. Pretty cool. I mean, the transmission's the only ones that use that I know about. But a gerotor pump, have you ever seen this little star-shaped thing? It looks like this. And it's inside a turning ring, and it's got a, grooves that match with these, but it's a little bigger. You seen that? I ought to have one in my hand to show you, but I'm a buffoon. I should have one right here to say, this is a gerotor pump. But you'll see those. That's the pump in the automatic transmission usually. And a lot of your oil pumps are like that.
That was on the Dodge.
Yeah. And, well, I'm trying to remember. The one you did?
Yeah, the 4.7.
Yeah, it was like that, I believe. But anyway, the long and the short of it is, that's a gerotor pump. I could show you one over. I got some oil pumps that come out of car. And that's one of them. And the vane pump is like a power steering pump is a vane pump usually. And it'll have this little thing with all these vanes going in here, and they can move freely. And this thing spins around. It's in an egg-shaped hole. Got me? And then it's got, on one side, if you look at it from the side, it's got, on this side, it'll have an open port over here. On that side, it's on the other side. So whenever those vanes swing out, they're creating low pressure. It's pulling oil in here. It's trapping it and putting it under pressure. And then whenever it comes over here, it's forced out that hole. See, by the time those vanes travel around, that oil is trapped. It's gone past the point where it was coming in. And each little chamber it's created by these vanes are what moves that out. Now the one that you're talking about, the variable displacement one, this whole housing is mounted in the transmission, and it'll have a spring. And it can move that back and forth and change the displacement. You'll see that. And hopefully, now that I've told you this, you're paying attention instead of sleeping like Tyler over here, you're going to wind up knowing what you're looking at. Head off the table, okay? All right, now let's see right here. We're going to have, so you're going to have a constant displacement only on a gerotor pump. A balance valve can be controlled by hydraulic pressure or spring pressure or both. And that's 10. That's 10. As you study your valve bodies, you'll run across that. Which of the following is not an advantage of using hydraulics? Flexibility, force multiplication, high pressure, or simplicity? How about C? That's not an advantage. Hydraulics have got high pressure. You got to contain that high pressure. The high pressure is what makes the work happen and all that. Let me do something about this. Hello. Hey. I don't want oil dry. I don't use oil dry here. Yep. We're done. All right. All right then. Which of the following statements, which of the following statements is true about a remote cylinder with a piston surface area half the size of the input piston? That's what I just talked about up there a while ago. Number 12, that's B, it travels twice the distance of the input piston. A remote cylinder with a piston surface has the size of an input piston. Now your remote cylinder would be your what? Hey, Willie? It's going to be your slave cylinder. That's your remote cylinder, right? You mash that with you mash your clutch, it moves it. All right, and so the slave cylinder that it's pushing has got a lot of area. It was big. Your little, the little cylinder was little, and it multiplies your pressure. See, and that's what they're talking about here. That's what this is, talking about. Okay, so you're basically going to travel what now? 13? Excuse me, 12. If it's a piston surface half the size of the input piston, does it travel twice the distance of the input piston? Ooh, think about what I just said.
It travel at half the speed.
Yeah. All right. Well, this is what we're talking about here. We got an input piston, and we've got an output piston. This one's bigger. This one here is going to travel what? Twice as far, right? And they're going to go. This is going to go twice. This is input. This is output. This is going to go twice as far, isn't it? Right? The bigger one's input. That one's going to go twice as far as that one if it's 2 times as big area-wise. Okay. The most common type of automatic transmission pump is that's number 14. That's the gear pump. Now the gear pump works similar to the vane pump and the gerotor pump as far as the fluid coming in one side, leaving the other. But the gear pump is going to have 2 sets of gears in there that are meshed together. And as they turn together, and I'm not really good at drawing gears real fast, but anyway, if you turn if them gears are turning in relation to each other, they're gonna force that oil to come in one side and go out the other side. Got me? All right. Okay. There you go. The gear pump and engine oil pumps, like the ones that are driven by the distributor that are down in the oil pan, those are gear pumps. The one that's around the crankshaft will be a gerotor pump. The Toyota Camry, the older ones with the timing belts, the timing belt drove the oil pump. Is there a problem with that, you think? Could the oil pump not work and the engine keep running? Not really. If the timing belt jumps, everything stops, right? Okay. Which of the following valves used in automatic transmission controls the direction of fluid flow? That's number 15. That's A. Switching valve. And the matching stuff, just leave the matching stuff blank. I'm not going to go over that today. Just leave it blank. But make an X on it.
Didn't matching stuff.
You don't have any matching stuff. Sorry, I didn't print it for you. So you don't need to go over it. Yeah, the matching stuff doesn't go. All right. Here we go.